Okay, I'm back, and now in our previous slide, we had made protoplanets. So essentially, the inner planets are pretty much finished. So we've made Mercury and Venus, Earth, and Mars. And you'll notice, though, that Jupiter and Saturn, Uranus, and Neptune, those gas giants that are in the middle part of the solar system, they're very small, and they're made of rock and metal. So in the cores of all of the Jovian planets, so we're talking about Jupiter, Saturn, Uranus, and Neptune, in the middle of all of these gas giants, there is an object about the size of the Earth. So it's composed of rocks and metals and ice. We're not exactly sure what kinds of rocks it's made of because of the intense pressures that are in the centers of these planets today. But back then, so at this point in history, you're going to have the cores of the Jovian planets are forming. However, they're going to get larger because they're going to start to collect ice. So the ice that was driven from the inner part of the solar system to the middle part of the solar system and the outer part of the solar system is going to get onto those planets as well. So the gravity of the Jovian type planets is going to start to collect the ice, and that's going to give more mass to those planets. And the more mass they get, the more stuff they get because they increase in their gravity. Now you notice that other dot way out there, it didn't. So that object really did not collect too much ice because there wasn't as much ice to be collected. So the further out you go in the solar system, the less materials you have to work with. And so that object way out there, which you can guess is going to become Pluto, did not collect as much ice as what the Jovians did. Okay, now the next thing that's going to happen is that the Jovians are also going to collect gas as well. So there's going to be a lot of gas in the middle part of the solar system, and that gas is going to be collected by those objects that are eventually going to turn into Jupiter and Saturn, Uranus, and Neptune. Okay, then the next thing that's going to happen is the sun finally gets hot enough that it ignites. It starts to have thermal nuclear explosions, and it starts converting hydrogen into helium. And when that happens, it gives off a tremendous amount of energy in the form of a solar wind that blows the remaining gas out of the solar system, so that you're left with the inner planets are composed of rock and metal. Then the middle planets are composed of gas primarily. And then the outer ones, like Pluto, well, they got some rock and they also have some ice on them. The planets continue to grow by accretion. So accretion basically means running into other materials. And they become heavily cratered. Now, how do we know this? Well, just look at the moon. So if you look at the moon, you notice it's heavily cratered. And that some of those craters go all the way back to the initial formation of the moon. Also, rings can form. So that, for example, all of the Jovian planets, so we're talking about Jupiter, Saturn, Uranus, and Neptune, they all have rings. So this is debris from the formation of the solar system that is in orbit around those giants out there. And then also they start to collect moons. So the more gravity that a planet has, the more stuff it can grab onto. Then, up until now, so up until this point, we thought that we understood how solar systems form. And then we started taking our telescopes and training them into outer space, and we started looking at other solar systems in our galaxy. And we found things the size of Jupiter, so they're made of gas, they're gas giants, but they are very close to the sun. And that really bothered astronomers because we know that those gas giants originate in the middle part of the solar system, not in the inner part of the solar system where some of these are. So we had to modify this theory of planetary formation to account for the fact that planets can migrate. A planet can change its orbit, and we're going to call that migration. And so we're going to cover that in a later lesson, but not right now. So I just want you to see for right now that after the solar system formed, there was some jostling amongst the different planets in our solar system. Okay, we're going to take a break, and when we come back, we're going to talk about what happened to the remaining debris, and then we'll also talk about why do solar systems differ from each other.